Our final speaker for this session, Diana Kurkovsky West, armed with a PhD in history and theory of architecture from Princeton, decided to try to understand planning and theories of scientific organization focused on post-war USSR. She must have done a pretty good job of it. She's currently the co-director of science and technology studies at the European University in St. Petersburg. So, Diana, I'm eager to hear what you have to say. Thank you very much.
Thank you. I'm going to start in a bit of an unusual place, I think, for a conversation about Russia, namely in Rio de Janeiro. But this image has become almost canonical for those in architecture who are very, very much concerned with this notion of smart cities or smarter cities. I've seen this in the New York Times. I've seen it in various other reproduced forms. This is IBM's newest integrated platform for running a city, looking very much like a space-age mission control room. The operations center in Rio is a giant wall of screens which show real-time video streams of jammed intersections, car accidents, power failures, weather events, activity in the favelas. It's kind of a monitoring system for security as well, and other problems that plague modern cities. Workers in white coveralls monitor these activities and manage the city's emergency response systems who, excuse me, sort of negotiating the microphone here. I'm trying to see how I can see my screen and not have the microphone in the way. I know, this is not very smart, is it? Smart, but maybe I'm not so smart, I don't know. Okay, let's go there again. Workers in white coveralls monitor these activities. They manage the city's emergency response systems. This really was created in response to a bunch of floods that they had, so this was an emergency response system in a sense, and also providing additional police for events like the Soccer World Cup that was held there last summer. And some of this data is shared with Rio's inhabitants. The center's Twitter feed maintains continual traffic updates, while the weather service Alerta Rio sends SMS messages to over 10,000 subscribers and warns them of weather emergencies. So IBM touts this platform as one of a kind in its ability to integrate information from dozens of sources, and most recently to offer what they call predictive analytics that allowed the city to establish budgets for capital improvement projects. According to IBM spokespeople, this would lead to smarter energy use, flexibility to allocate resources when and where they're most needed, creating more better use of taxpayer dollars. And this is kind of a hype, right? Everybody's jumping on the smart cities bandwagon these days. Places from South Korea to Canada are getting on board for these kinds of initiatives, right? Smart everything is the name of the game. Smart buildings, smart cities, smart towns, smart cars, you name it. In an interview with the New York Times, the IBM executive Guru Banavar stated, quote, "Smart is about information. Once you have the information and understand it, you know what you do with it, you're halfway to smart." So what does any of this have to do with Soviet Siberia? Of course, in part I'm being provocative, but only in part. In reading Banavar's enthusiastic statements regarding information, I had a distinct impression that I've kind of heard this story before. Not in conjunction with emergency response systems per se, but with the idea that by processing vast quantities of information, large and complex systems could be made much more manageable. And this was very much a premise of mid-century research in the field of cybernetics, which is where I did a lot of my dissertation work. Developed in the late 1940s by a number of scientists, among them most famously Norbert Wiener, who also had traveled to Russia and was translated in the 50s. Norbert Wiener, Rossa Ashby, John von Neumann, Stafford Beer, there were many others. Cybernetics was a generalized theory of communication and behavior in human and machine systems, human and animal systems. And this theory was based on the idea that through continual information feedback, the system, even a very large and complex system, could become virtually self-regulating. The idea was actually almost instantly appealing to American urban planners, looking for methods of controlling, rationalizing, and systematizing urban growth at a time when cities became hotbeds of social disparity and crime. But after the initial period of ideological denunciations that were very well articulated in Slava Gerovich's book, From Newspeak to Cyberspeak, cybernetics also became a very enticing agenda to the Soviet planning establishments and the scientific establishment as well, for reasons that pertain both to this dream of centralized control over all aspects of a very large command economy, but also, I argue, had interesting implications for regional planning and for thinking about the local in conjunction with the national. So my presentation today focuses on a theme that kind of undergirds both the IBM Smarter Cities interface and the ideas that grip the late Soviet planning establishment, namely this theme of a vast quantity of information as a means of managing and regulating complex systems. This is the larger interest of my book project, which looks at the impact of what I call cybernetic thinking on Soviet theorizations of space. But here I'm going to focus on one chapter which deals with the territorial and production complexes, территориально-производственный комплекс, which was this key unit of regional planning in the Soviet time. And this is a complex idea. It's a feature of Soviet regional planning that strategically interlinked production, agriculture, transportation, and other key elements of a given region in some sort of an optimized manner. I will look here at the work of a late Soviet planning institute, an institute that still exists today in another form, but still associated with the Academy of Sciences, namely the Institute of Economics and Organization of Industrial Production. It's an institute located in Novosibirsk. And I will focus on their research into what they called dynamic mathematical modeling. Moreover, I'd like to highlight, moreover, I'd like to highlight an interesting thread I found in the work of this institute, namely the focus on the environment. And one of the people I'm going to talk about actually still teaches at the Novosibirsk State University. And I'd like to embed this in a bit of a greater context of mathematical modeling together with this new kind of local global or local national paradigm. So this is not a great map, and I apologize for this, but getting good Soviet maps of anything is a huge problem, as you all know. So this is an incredibly schematic map from the 1950s of the various territorial production complexes in the Soviet Union. This is about the best I can do at the moment. But the Soviet territorial production complex is actually a very slippery notion. Every piece of literature I look at defines it somewhat differently. And it means something a little different in various points in time in various regions, but as a whole, they were regional planning units that combined industry, natural resources, and urban space or settlements into immense, comprehensively planned, integrated systems, largely for the sake of efficiency and a more effective use of resources. Really, a lot of these ideas are based around extraction of natural resources of various kinds. The concept of a TPC, I'm just going to call them that, predated the advent of cybernetics. It was developed by the economic geographer Nikolai Kurkovsky in the 1940s as a theory of economic regionalism. And it was aimed at maximizing the economic productivity of each industrial zone in the USSR. The idea stipulated that industries should be united in their shared use of natural resources, which was more efficient somehow, and Kolosovsky called them energy production cycles. So they had to be sited in proximity with the industry, with the resource in question, and several adjacent industries would share the resource. Kolosovsky's conceptualization divided the entire country into economic regions developed on the basis of production, essentially forming a nationwide network of TPCs. Every one of these economic regions combined industries, natural resources, transportation, workforce in some sort of a comprehensive manner. It was supposed to become predominantly self-sufficient and really only allow minimal inter-TPC trade and resource sharing. So this system was really meant to eliminate redundancies and waste of time and resources. So to this end, each region was sort of to do its own developing in terms of housing, agriculture, and so on and so forth, and maintain a high degree of economic independence. There were several strategically important TPCs constructed in the Stalin era, most notably the coal mines at Kuzbas in the 1930s, and other regional plans like Mineralные Vody in the Caucasus, Donbass region. However, these were very different from the late Soviet projects that I looked at, in that they paid much closer attention to architectural and engineering requirements rather than the overall economic and territorial integration. But with Khrushchev's rise to power, the focus of TPC planning began to change, it began to expand. And a lot of Kolosovsky's research, who was already dead at the time, it was actually revived posthumously. A lot of his works really are beginning to be published heavily in the 1960s. But this was also very much part of Khrushchevian reorientation of the ministry-based system toward his regionalization efforts of the entire country, which of course was overturned once he was ousted from office, but with that new kind of hybrid system that emerged afterwards, it nonetheless, the focus on TPC planning nonetheless remained pretty heavy in late Soviet literature. Even more significantly, of course, Siberia was beginning to feature heavily already in Khrushchev's imagining of the future of natural resource extraction. It had actually already, as you I'm sure know, had been a feature of this kind of imagination of what you can do with natural resources since the Tsarist times. But with the construction of the Baikal-Amur main line, this became a real major issue because a lot of new towns were emerging and a lot of new projects were being put into place. As Christopher Ward, of course, discussed in his book Brezhnev's Folly, the construction project brought back the themes of Prometheanism in Soviet large-scale industrial construction. It rallied the country's youth around another epic triumph of engineering against hostile nature and created an immense media apparatus advocating the bomb as the single most important project of the era of developed socialism. The Bratsk GES, which we've already heard several times about, became the backbone of one of the most significant TPCs of the late Soviet era, the Bratsk-Ustilimsk Territorial Production Complex. And I'd like to now spend a few minutes discussing it in order to illustrate what a TPC optimization might entail. So the Bratsk GES became the principal element of the Bratsko-Ustilimsky TPC, one of the most productive TPCs in the region, encompassing the middle sections of the Angara River and adjacent territories together called Priangarye. The bulk of the energy produced by the GES served to power an immense aluminum production plant, Bratski Aluminievy Zavod, as well as the Bratsk and Ustilimsk timber industry and paper mills. In addition to the city of Bratsk, the TPC included other cities and towns like Ustilimsk, Zheleznogorsk-Ilimsky, and Vikhrivka. Zheleznogorsk-Ilimsky is the region's mining center with a prominent open iron ore pit and processing industry, and it's on the bomb line between Bratsk and Ust-Kut. Other elements in the TPC include a chlorine plant, one of Russia's largest cellulose plants, while the region's ample forests support quite a large timber industry. So strategically, TPC optimization was seen as part of optimizing the economic structure of the Soviet Union in its entirety through controlling and mathematical modeling of the smaller scale units, all the while considering the big picture. And I'm going to look now in particular at this institute, which was formed in 1958 as an arm of the Soviet Academy of Sciences in Novosibirsk. Of course, this is also part of Akademgorodok, right, the new experimental science city that's created at this time in Siberia. The institute had branches not only in Novosibirsk, but in Krasnoyarsk, Barnaul, Tyumen, Irkutsk, and others, and produced a considerable amount of research coordinating Siberia's economic and regional planning. There was a head researcher who actually spearheaded a lot of the particular kinds of modeling I'm looking at. His name was Mark Bandman. He is no longer alive, but he was a Novosibirsk native, which is kind of rare at the time. He headed the Department of Mathematical Modeling at the Institute, and he's often credited for fully articulating the scientific theory between TPC planning and optimization. His colleagues describe him as, I like this description, he was born with geography in his blood. His name appears on hundreds of publications emerging from the Institute between 1957 and 2003. And his method was sort of famous for its insistence on what he called dynamic mathematical modeling. A particularly important element of the TPC planning literature was this insistence that, you can't just optimize all features within the system and let it roll. You have to account for change over time. And this is actually different from a lot of the earlier Soviet attempts at mathematical modeling, which entailed kind of these static systems which are not going to change. So here we have several elements to this discussion. Firstly, regions need to be designed in a manner where all economic, geographic, industrial, and settlement aspects are accounted for, and their relationship is somehow expressed mathematically. However, this itself is not sufficient. Models also need to be designed in such a way that they can change, that they can include unknown variables, and of course, they all need to still function within this national network, right? So they need to be optimized on both a local scale and on a national scale. This is particularly visible in one of the publications that came out of the work and was actually translated into English, so it gained some prominence. It was called Regional Development in the USSR, modeling the formation of Soviet territorial production complexes in 1976. And they articulate these new methods of nonlinear modeling for optimizing TPCs, looking at scheduling, efficiency. They even have something that looks a little bit like game theory. So they're really messing with this idea of dynamic systems that can change. But what marks the language of the entire publication is this interest in optimization, flexibility, but also in the notion that somehow this data needs to be continually collected, right? So data on all the production facilities needs to be collected. All the geographic data needs to be collected. It needs to be monitored. It needs to be plugged into these complex mathematical equations, and you will have your optimized answer for that particular point in time. The problem is, of course, that they're doing all of this without computers. So you have these vast documents, continual documents that are produced by the Institute, very complex. And it looks things like this. I'm not going to even attempt to go through this, but that's more or less what all these documents look like. They're very mathematically sophisticated, but there is an assumption that somehow in the future, once the Soviet economy is cybernetized, you can actually make it work. But for now, it needs to remain somewhat theoretical. There's an interesting dimension to this research as well, which is an ecological dimension. There was a researcher, Burmatova, whom I've mentioned before. She's still in Novosibirsk. She was quite young at the time, working with Bandman on the notion of optimizing the ecological aspect of these territorial production complexes. And she did some interesting work which actually responded to another very important document that came out in 1972. It's the Limits to Growth model that was produced from data collected at MIT. It was a computer-generated model that was basically referred to as a computer curve to doomsday, right? It basically said that, if we keep industrializing the way we're going and the way the world population is going, we're going to run out of resources. And she essentially said, well, no, we're not going to run out of resources because we just haven't optimized them sufficiently. And what she advocated was focusing on the local scale and looking at these territorial production complexes and bringing the economic variable into the mathematical model. So she wrote, quote, "A large number of problems can be resolved only at a local or regional level. In a number of cases, particular problems of conservation, which developed as local, can, if not attended to, spread to a large territory and become regional, national, and even global. Thus, in order to prevent small problems from becoming large, one must first and foremost solve the problems of the small scale." And she continues, moreover, solving the same problems of conservation can be fundamentally different on various territories because of specificities, both natural and economic. So once again, you see this idea that on the one hand, there are specificities, they're very local. On the other hand, there are these kind of meta methods, right? Somehow cybernetic methods that can be used to do some data crunching, to adjust these visions, to make them better, to solve, to optimize, solve a lot of the problems with ecology. She cites a number of mathematical researchers and also American regional planners, Walter Izard from the American Regional Planning School. She polemicizes with a number of them. But there is this emphasis here, and it's an interesting emphasis because she also talks about how the national may not understand the problems of the local, right? So they really need to arise from the local scale. So the problem with environmental degradation would be solved through a mechanism that would continually reevaluate the goals of TPC optimization vis-a-vis its environmental impact and be used to balance production costs against the costs to the environment. So she comes up with this model that would do this. And this leads me to my final point about TPC planning. For a critical assumption that exists in all this research on TPC optimization, and this point goes back to my interest in cybernetic thinking and a certain kind of positivism and idealism that it implies. It is an assumption that even very complex economic and spatial systems can be continually re-optimized by having access to vast quantities of real-time data, which of course they didn't have. So there was a lot of dreaming about what they'll be able to do with these models once they have the data. In this case, a kind of a smart Siberia. Theories of Soviet regional planning in Siberia envisioned the continually fine-tuned and re-optimized network of economic and spatial relations among the industries and settlements. They also recognized that new informational input would result in renegotiation of the optimal relations and would therefore leave room for growth and change. In the end, the research served to highlight the potential of information for managing Soviet geo-economic structure. Its application to the actual planning and economy, however, would be dependent on the ability to access, process, evaluate, and feed data into a network of future computers. It was tacitly assumed by the researchers and actually overtly stated on a few occasions that computerization and cybernetization of the Soviet spatial and economic structure would take place at a future date. In fact, one of the people I interviewed basically said, well, they promised us cybernetics, but they never gave us cybernetics. So I'll end here.